See ma, here for fixed array we are writing into, see, one dimensional array. Tick 0, 1, 2, 3, 4, 5. How many locations? 6 locations. Array 1. Array 2. This is called verbose form. 5 down to 0, which means 0 to 5. So total 6 elements. So 0 to 5 elements we are pushing in. Array 3. This is two-dimensional array. The two-dimensional array, how we are writing? First, this is row 1, column, row 0, column 0, column 1, column 2, column 3. Row 1, column 0, column 1, column 2, column 3. Likewise, see here, see here, while writing, how we are writing? We are writing 0, 0, 0 through like that, right? But for accessing, it will be opposite. I'll show you the output. See, 2 3, 2 2, 2 1, 2 0, 1 3, 1 2, 1 1 1, 1 0, 0 3, 0 2, 0 1, 0 0. So 0 0 is 11th element, right? This is 0 0 is 11th element, right? So the first row this will come. Second row, third row. In each row we have 4 columns. 0 1 2 3 4. See, 0 1 2 3 4 5 5 6. See, while writing 0 0th location is 0, but for accessing 2/3 location is 0 0 value. So for multi-dimension it will be 2 dimension. This will be definitely opposite. That I wanna convey. I have explained about packed array and unpacked array. Same, this is also array. See here, packed means before variable declaration of the size of width of the variable size will be before. Pre, packed, pre means before, prior, before. 7 down to 0 declaration will be there. Unpacked means opposite. See, where after variable 7 down to 0. That is only the difference. See here, array 5 packed array declaration. This is called packed array declaration. So 7 down to first, these are called columns. These are called rows. Sorry, these are rows. These are columns. So array 5 of 0. These are all rows. This is also rows. These are like what is the width of this first dimension? 7 down to 0. So bit array 5 of 0 is 7 down to 0 8 bit. 7 down to 0 8 bit. Array 5 of 1 5 down to 0, that is 5. Array 5 of 1 7 down to 0, that is also 8 bit. Array 5 of 2, so 0 1 2. So array 5 of 2 7 down to 0. This is also same. Packed and unpacked. See here, unpacked array means right side declaration is there. So it is called unpacked. So for 0th location, 7 elements. For 1 location, 7 elements. For the second location, 7 elements. So this width will be by default, this width decided by the architecture processor. that will be definitely 32-bit or 64-bit. If you are using 7-bit, effectively you are not using. You are not using effectively these bits. You are wasting. In unpacked array, you will waste. So better opt is going for, if it is a bit slice is there, then it's better to go for packed array. If you are using instead of bit here int, then it's better to use this unpacked array. Dynamic array unpack. See, this is one dimensional unpacked array. See, dynamic array representation. Data type, array name, uh, square brackets, open closed square brackets. For this new of elements we will give within the square brackets. See at the new of the allocation of the storage. See size of brackets. This will give the size of this dynamic array. Delete will delete it. These are two methods it have. See here, this is an example. D array 1. This square brackets, it is we don't know what is the size at the compilation time, but at the runtime memory allocation will be happen at runtime. Four elements we want. What is the type? Bit type. What is the width? Sorry. Okay, what is the size? 4. This is also, this is we are allocating at the dynamic runtime. This is called runtime allocation. This is called runtime allocation. See, D array 6 elements. We are putting 6 elements. D array 1, how many elements? 4 elements, right? 0, 1, 2, 3. For fixed, how we will give tick here? We will put, right, tick. Here we need not, for dynamic array we need not to put. Okay. If you wanna allocate, okay, for with the help of iterator, or for each loop. See here, this is one of the way. For D array of array 1, array 2, how many elements are there? 6 elements. 6 elements were declared at the runtime. So what are those values? D array 2 of j equal to j. Initial value of j is what? 0. So 0 to 5 it will go. So D array 1 will be 0, 1, 2, 3, 4 elements. Here 0, 1, 2, 3, 4, 5. D array new of 4. So 0 to 3. D array 1 of array initialization. This is called initialization. This is memory allocation. Initialization, these are the indices, index. Okay. This value will be, these values are initialized with these indexes. These are the location. This is the location addresses. So 0, 1, 2, 3. 3 elements. So 4 elements were occupied in these 4 locations completely. Change the length of the array after declaration or initialization. After initialization is happened or declaration is happened, again you want to change it. Uh, you can change with the help of dynamic array. With the fixed array, you cannot change it. For that, see here, dynamic array 1. Earlier we have 4 locations. Now I kept like the new of 10. Dynamic array size of 10 elements it will go. But what will happen means its previous values will become nullifies. Its previously 0, 1, 2, 3 values are there, right? 0, 1, 2, 3 values, these will become 0. Whenever new allocation will be happen at the same thing at that time, its previous values will become 0. To avoid that, we need to use one more syntax, new of 10, the same variable within the brackets d array 1. So its previous values will be retained. See here, it's whenever you will do d array new of 10, d array initially, uh, here your memory allocating how many locations? 4 locations, 0 1 2 3. And array initialization, how many locations you are initializing? All the locations, 0 1 2 3, 0 1 2 3, you are initializing the values in memory, and increasing the size by overriding the old values. If you want to override the old values, overriding means new value will be occupying on old value. So D array initially 4, now new of 10. So 10 values will be allocated, 0 to 9. So what is happening? Initial values, whatever it is present, 0 1 2 3, those will become nullifies. Okay, it will become zeros. So D array of new of 10, same, 10 is there within the brackets. If you mention like D array name, then old values will be retained and new values will be empty spaces. These are filled with zeros. See here, if you want to delete your array, you can delete with the help of delete method, dot delete method. See, dot operator is used to access each and every method, variable or property. Variable or property both means same. Method also we can, if you want to access, then we can access with the dot operator. Dynamic array declaration. See, this is the full code. You can run it. Similar output. Initially 0 to 3. See here. 0 1 2 3. D1, D array 1. D for each D array 2. D array 2 is what? 6 elements. So for each D array 2 of J, D array 2 of J equal to J, which means 0 to 5 you need to get. See, 0 to 5. Because J iterator, always our variables or everything will start from 0. So max value it will go for n minus 1. So 6 locations we give, 6 minus 1 5 max location is. Why? Because it is not starting with 1, it is starting with 0. Dynamic array delete method. Here d1 d2 deleted, dot size operator, d array 1 dot size will give the size of the elements. What is the size of the elements? D array 1 d array 2. After deleting we are deleting. Initially, before deleting, what is the size? 2 comma 3. After deleting, 0 0, size will be 0 0. Resizing dynamic array. Okay, today go through this session. Tomorrow onwards we will go for the queues. This is the same thing we discussed earlier. Resized, resized with the previous value within the brackets. If we keep it, then it will get resized. The same concept only he explained with the example. Tomorrow onwards we will go for the queues. Do you have any doubts in this session? Do you have any doubts in this session?